Alright, so I'm going to show you how to do regression in Excel. You would do this, for example, if you have two continuous variables like we have here. You might want to use regression. In this example, we were looking at the swimming speed of Daphnia, and we've got a picture of a Daphnia here. It's a small zooplankton. And we varied the temperature and measured the swimming speed. And so temperature is a continuous variable, and swimming speed is also a continuous variable. You'll see here that we've made a scatter plot. Temperature is the independent variable, and swimming speed is the dependent variable. Swimming speed depends upon temperature. And you can see that there seems to be a pretty decent relationship. As temperature goes up, swimming speed also goes up. But of course, we want to apply a probability to this. We want to run some statistics, and the statistics that we're going to use, or the stat we're going to use, is regression. So here's how we're going to do this. We're going to go to the Data tab, and we need to go to the Data Analysis button. If you do not see this button, you have to install it and or turn it on. And I have a separate video showing you how to do that. It's very simple. You Mac people, it's going to be a little bit different. This is for the PC version. And so this window that comes up has many statistical tests, and the one we're going to use is regression. So I hit OK. And I've already got some things filled out here. I'm going to delete them so I can redo them. So first we want to input the Y range. Y is always the dependent variable, right? You want to predict what Y is based upon X. And so in this example, the dependent variable is swimming speed. So I'm going to come over here and select swimming speed. You'll note that I selected the header as well as the numbers. That's on purpose. The X range is the independent variable, which in our example is temperature. So I do the same thing. The header and the numbers. Since I selected the headers, I want to make sure that labels is checked. This will make it just easier to follow what's going on later. And I want to put the output on a new worksheet just because it's easier. So I'm going to name this worksheet Reg. And that's all I really need. When I hit OK, I get a new worksheet named Reg. Here's my output. It's all bunched up. So I'm going to select the entire sheet. I'm going to go between a couple of columns and double click. And now all the cells are fit properly. So these are our regression results. The most important result is our p-value. Recall that the p is the probability that the null is true. And you can find that down here at the very bottom under the coefficients table. Here we have the intercept and then our independent variable. And if you come over, you see p-value. We have a p-value for the intercept. That is just testing whether or not the intercept is equal to 0. We don't care about that. So do not use this p-value. We are interested in the effect of temperature on swimming speed, and that is related to this p-value. The null is that temperature does not have an effect on swimming speed. And if you look at this p-value, you see that it is very, very small. This is 5.02 something something e to the negative 0.5. That's times 10 to the negative 5. So you'd have to move this decimal place to the left 5 places. That is much, much less than our value of 0.05, which is the alpha that we use most of the time. So this is a very, very small p-value. It means there's a very, very small probability that the null is true based on our data. Therefore, we can feel confident in rejecting the null, and our alternate hypothesis is that temperature does have an effect on swimming speed. Now you can go a little bit further, and you can look at the coefficient for temperature, and you see that it's a positive value. That means they have a positive relationship between temperature and swimming speed. As one goes up, the other goes up. If I go back to the spreadsheet, you see that's true. As temperature goes up, and not to the spreadsheet, I went back to the scatter plot, excuse me. As temperature goes up, swimming speed goes up. And that's confirmed by this coefficient, which is the slope of the line that's fit to those points. And that's great. And there's one other thing I think you should pay attention to, and that's up here, and it's called the adjusted R squared. You have many R squareds, but we want to look at the adjusted R squared. This is a value that tells you how well the points fit to the regression line. Down here, we are coming up with a regression line to fit all those points on the scatter plot. This tells us how close do those points fall on that line. It's a number that runs, it's another sort of probability, more or less. It runs from 0 to 1. Higher is better. This is a 0.87 adjusted R squared. That's very good. So just to show you how this all relates, I'm going to go back here to the scatter plot, and I can add a line to fit to those points. I'm going to select the points and then right click. I'm going to add a trend line. If I come over here, I'm going to do a linear trend line, and I'm going to display the equation on the chart. And if I come back over here, you see that we've added a line of best fit, and we've given the equation. And look at these values. The slope of this line is 0.2637. Go back to our regression stats, 0.2637. The y-intercept of this line is negative 3.1527. Negative 3.1527. How about that? So regression fits the best line that it can to your points. The stats tell you, is the slope of that line significantly different from 0, which means does the independent variable have an effect on the independent variable? And the R squared tells you how well those lines, how well the points fit those lines. And you see these points fit that line very well. So that is regression in Excel. And let me know if you got any questions.